Hello, everybody. My name is Daniel Todd, and today I'm going to be talking to you about my co-op experience at Storm Technologies. And I was the role of an engineering co-op at this company. So when I first heard about Storm Technologies, which is at the engineering picnic a couple years ago, I assumed that they provided weather-related services, as the name might suggest. But it turns out Storm is the name of the owners of the company. They've owned and operated this company since 1992, and they actually operate within the energy sector, working in power plants. My co-op supervisor is Sean Cochran. He's a licensed PE and has been with Storm for many years. And so far, I've completed 1 out of 3 co-op semesters. So what does Storm Technologies actually do? Well, they perform what I like to call combustion tuning. So basically, they go into a power plant and they look at a variety of factors to make sure that the power plant is running as efficiently as it possibly can be. And that involves a lot of things, but mainly airflow testing, gas sampling, such as flue gas, and coal sampling. So your airflow testing is going to give you a good idea of, your actual airflow velocities throughout pipes and ducts. That's very important. We'll touch on that later. Gas sampling, like I mentioned, flue gas. So that's actually what's in the gas itself. Oxygen, nitrogen oxide, carbon monoxide, all these things play a huge part in the combustion process as a whole. And then coal sampling. So, your fuel is very important in a power plant. How fine it is, how much energy is actually left over in the coal after it's been combusted, things like that are very important. And so Storm will do a lot of testing, and they implement changes to increase the power plant's combustion efficiency. And they also fabricate a lot of parts to increase efficiency, and a lot of them are airflow related. But they have a sister company called Fabricated Solutions that does all of this, and this is all very niche stuff here. I mean, Storm Technologies is, one of very few companies in the United States that actually does this kind of work. So they have a lot of valuable knowledge and experience behind them. So to help you get a better picture of what I'm actually talking about here, let's take a look at a coal power plant. So this is a very basic drawing, this is very simplified, and I'm going to try to keep it that way so you can understand, but essentially, here on the left side, you've got your coal coming in. This is usually by train, but these, as you can see in the picture, they are pretty big lumps, so you can't actually burn coal like that and expect, a high level of efficiency. So that coal comes into the plant, it's actually pulverized somewhere in here. And that pulverization process turns it into a very fine powder. And if you know anything about fine powders, they have a much higher tendency to combust. So a finer powder is what you want here. That's fed into the boiler itself. This is the boiler through ducts, and it's blown in by air. And it goes into a burner. The burner ignites it, it combusts, and it heats up the water in these tubes here. And this is not, accurate necessarily, but these tubes are all along the walls of this boiler. It's called a water wall, and basically the water turns into steam, and it drives this turbine here and produces power. That is, the basics of a power plant. But hopefully that helps you out throughout this. So I mentioned that they do testing in power plants. Here are 3 tests that I have performed, that Storm performs quite frequently. I would say these are 3 pretty common tests here. So your HVT testing. HVT is high velocity thermocouple. And from thermocouple in the name, you might get the idea that they are testing temperature, but also oxygen content, carbon monoxide, and nitrogen oxide. So this right here is actually a plot of our HVT data. And this is plotted in kind of a topographical sense. So it's like looking at a map almost, a topography map, of course. But what this gives you a really good idea of is, stratifications, like how are different parts of the boiler being affected differently. So this is actually the boiler, this box. You've got ports that we've tested in, and then you've got the depth. So, we come in on each side of this boiler and get all these points to map it into this. So this is a good representation of your entire boiler. But as you can see here on the right, there's a lot of high temperatures here. And, it's kind of our job to figure out why that is and how we can adjust it, because obviously you don't want, things to be super unbalanced here. All right, so coal sampling, I mentioned earlier, your fineness and your combustion. So your coal does need to be a certain fineness to be the most efficient. And it also, you want to make sure that the coal that you're burning is actually like burning all the way through. And that, that's a lot to do with your combustion process itself, but that's a really good insight into how efficient is your process as a whole. Because if you're burning coal and you're not getting, the maximum energy out of it, you're doing something wrong. Then primary air, I think I mentioned earlier, that's just velocity. So primary air is actually what's carrying your coal up to the burner. So if that's not right, then you're probably going to have a fuel issue there. So these are all just very important things to look at. So as far as personal impact on the company goes, I've been a part of a few projects here that I believe has had an impact on the company as a whole. This is the continuous flue gas monitoring system, and by the name, we're monitoring flue gas with this. We have a current system in place that's actually a portable system that does this exact same thing, but the idea of this project was to be able to implement this system into a power plant permanently, and therefore that does require different specifications from these components. To try not to get too into it, basically flue gas has a condensing point where it releases sulfuric acid, and that acid can corrode, a ton of different components. So having to install this permanently, we're going to have to look at how can these components withstand this, and that usually means, more expensive materials, just more expensive as a whole. And then, we're looking at potentially heating the sample lines, so we reduce the amount of condensation, and that requires a higher temperature requirement. You can see it just keeps going. So finding these actual components was very difficult. So these solenoids here, obviously I just made these in SolidWorks. That's not what they actually look like. I mean, it's pretty close. But these took me weeks to find because, at a good price point. It's kind of like the triangle you have here. It's like choose 2 out of 3. Well, price is usually, going to go up as it gets more specialized. So these specific solenoids, I think these are like $30 a piece. My next best alternative was, I think, about $350 a piece. And that was a no-go. I mean, we've got how many of the solenoids here? That's 6. And then we have a total of 16 of these manifolds. So, I mean, that adds up real quick. Anyway, so that was a fun project in itself, just finding these solenoids. But then I actually made these manifolds. So if you're not familiar with a manifold or solenoid manifold, it's essentially a really efficient way to route solenoids together. So if I had all 6 of these solenoids outside of this manifold routed individually, you'd have so much tubing and just loss of space, and it just would not be a good system. So what this essentially does is puts these together in a form that is super efficient. It's just perfect. So what we have here, you've got inline filters here, you've got some T filters here. They're both the exact same system, just different options. But I mentioned flue gas, right? So the flue gas is coming from the boiler, and you've got 4 points per probe, and you've got 16 probes. So this would represent 1 probe here. And each one of these lines is a different point inside of that probe, but that's, getting ahead of myself here. So the flue gas would travel into these filters, and that's just going to filter out any additional particulate matter that might make its way through, because that could damage the solenoids and the gas analyzer down the road. But the gas comes in here, and then it's basically, it's going to go one of 2 ways. So down here, that's your purge. So if you turn this solenoid on, it's just going to purge all this gas out to atmosphere or wherever it's going. And then this upper manifold block here, that's actually going to your gas analyzer. So each one of these sample lines can be tested one at a time. There's only one sample analyzer for this entire system, so obviously all 64 points can't be continuously sampled. So we have to pick one at a time, and that simply just routes them here. And these are just for, protection, so they can be closed when they're not open. That's essentially it. But I designed this from the ground up. I took these filters from a company. I just roughly mocked them up so that I could put them on here. And, this is a really fun project. It taught me a lot about SolidWorks, taught me a lot about flue gas and power plants as a whole. And I really am looking forward to potentially seeing this happen in the future, but we'll see. So another thing I did here is basically a newsletter refresh. So I took these old newsletters, decades old, and redid them to make them look more professional, more modern, more sophisticated. And that's pretty much it. And this is not necessarily related to engineering, but it's a really good kind of graphical design practice, and I enjoyed doing it. I learned a lot about it. And, reading through all of these are actually pretty substantial write-ups of, important things that go on in the power plant industry. So that was definitely good. So overall, as you might imagine, there is a ton to know about power generation and power plants as a whole. So while I have learned a lot, there's still, that's just the tip of the iceberg. So I'm looking forward to learning a lot more in the next 2 rotations of this co-op. And most people, myself included, don't really realize the extent of what goes on inside of power plants. Before I started this job, I literally had no idea. I mean, I've taken thermodynamics and we talk about combustion cycles and whatever, but until you really see it, you have literally no idea. So it's a lot. And everything that I've learned so far will just continue to add on and multiply my knowledge over the years, and hopefully, I can get a solid grasp of this stuff by the end of it. Uh, so this is actually the first job that I've had that directly ties into my major as a mechanical engineer. And I would kind of equate this job to an engineering lab course, or any lab course in general, really. So, testing, they do testing initially, you kind of form some hypotheses, you analyze some results, and you make some changes to improve efficiency. Redo the testing to make sure that those changes came out the way you wanted, and then write a report with your results. And this is a pretty common structure seen in engineering, I feel like, but it's awesome to be able to get a taste of this in a professional environment. And I would say this job has definitely enforced the principle that the quality of your work is reflected directly in the outcome of your work. In other words, if you don't maximize your input, you can't expect maximum output. So, this job is very testing heavy. Everything results wise that comes from this job is based on testing. So, if your tests aren't up to par, if you're not doing things, in accordance with ASME code or whatnot, you're really losing out on some potential benefits. As far as my career path, I have never really had a firm grasp on what my career path might be, but this definitely helps me narrow it down a little bit. I never thought about the energy industry really before this job. I mean, I never really considered it. It's definitely a huge industry. But this could help shift my career intentions. And like I said, I still have 2 more rotations to go. So whether or not I stick with the energy industry, I'm not sure now, but maybe, at the end of this co-op experience, I'll have a much better idea. And if you want to look more into Storm Technologies, you can visit their website at stormeng.com. They have a ton of cool publication. And I had mentioned, I think, my newsletters are all up there, all the ones I've redone. There's a ton of good information there, and there's a lot you can learn just from going on their website. And as I said in the beginning, my name is Daniel Todd. I'm a senior in mechanical engineering, and if you'd like to reach out to me about any of this stuff, you can find me through email or LinkedIn. And I hope you all learned a few things today, and thanks for tuning in.